Hello everyone, my name is Diksha and I am from the Bodhi Academy. Today I want to discuss Polymers chapter from 12th standard chemistry, which is the simplest chapter carrying minimum marks. So let us start with the polymers. Polymers, we know in our day-to-day life we use different types of polymers, that is plastic, we can say plastic buckets, polythene bags, then synthetic clothing materials and tires, toys, gears, everything that we use in our day-to-day life, it is polymer. And then the word polymer, it is coined from two Greek words, that is poly means many and mers means unit, so many units they give polymer. Now, what is polymerization? The process of formation of polymers from respective monomers is called as polymerization. Now, some reactions regarding polymerization you've studied in 11th standard, that is a hydrocarbon chapter. In that, we have studied that many small units combine to give polymers. Now, based on that, we have classification of polymers. So, under this classification, we have three subcategories. Okay, so first we have natural polymers, which occurs naturally. Natural polymers, then semi-synthetic polymers and synthetic polymers. So we have different types of polymers. So natural polymers they are found in plants and animals. Their examples are proteins, cellulose, starch and resins and rubber. Semi-synthetic polymers, that means they are derivatives of cellulose. Cellulose is a natural and derivatives of cellulose comes under semi-synthetic polymers, which is cellulose acetate, that is rayon, and cellulose nitrate, they are the examples. And last is synthetic polymers. A variety of synthetic polymers such as plastic that we use widely, then synthetic fibers, that is nylon 6,6, and synthetic rubbers, that is Buna S, they are the examples of synthetic or man-made polymers. Then they can be also classified on the basis of their structure, molecular forces of attraction and modes of polymerization. So let us see types of polymerization reactions. So in this, first of all, we will see addition polymerization or chain growth polymerization. So in this type, molecule of the same monomer or different monomers, they add together and they give large scale of to form a polymer. So for example, we have alkenes, alkadienes and their derivatives. Then we have free radical mechanism. Now we already know what is free radical mechanism, wherein the radicals are formed and then we get the product. So this is a mechanism of addition polymerization, meaning how addition polymerization takes place, it's given here. So what here we have different steps here. First is chain initiation steps. Chain initiation steps in which we initiate a radical over here. Okay, we have phenyl radical and here acetate radical. Then chain propagating step in which we form the polymer. Okay. Then one more thing important over here is the homopolymers and copolymers. Now what are homopolymers? Addition polymers formed by polymerization of a single monomeric species are known as homopolymers. Meaning we have only single monomeric species here as the raw material, and here example we can take as polythene. Then copolymers are, only the difference here is they are from two different monomers. So polymers made by addition polymerization of two different monomers are termed as copolymers. So here example is Buna S, which is formed from polymerization of buta-1,3-diene and styrene. So here it is given Buna S, it is formed from buta-1,3-butadiene and styrene, which gives us Buna S. Then some important addition polymers. Now we will see examples of polymers, addition polymers. First is polythene. Polythenes, they are linearly or slightly branched long chain molecules and capable of repeatedly softening on heating. We have two main types here, low density polythene and high density polythene. Now what you have to know in low density polythene, that it is obtained by the polymerization of ethene under very high pressure, that is 1000 to 2000 atmosphere and at temperature of 350 to 570 Kelvin. It is also known as LDP, and its uses we need to know. So this is chemically inert and tough but flexible and poor conductor of electricity. So it is used in insulation of electricity carrying wires and manufacture of squeeze bottles, toys and flexible pipes. Then high density polythene, it is formed when the polymerization of ethene takes place in a hydrocarbon solvent in the presence of catalyst, and that catalyst name is Ziegler-Natta catalyst. And here the temperature used is 333 to 343 Kelvin under a pressure of 6 to 7 atmosphere. Then it consists of linear molecules and have high density due to close packing, and it is also chemical inert and more tough and hard. So this is used for manufacturing hard plastic, that is buckets, dustbins, bottles, pipes, etc. So this is about high density and low density polythene. Next very important addition polymer is polytetrafluoroethane, which is commonly known as Teflon. Now it is manufactured by heating tetrafluoroethane with free radical or persulfate catalyst, and pressure used is very high. It is inert and resistant to attack by corrosive reagents, and it is used in making oil seals, gaskets and also for non-stick surface coated utensils. So this is very frequently asked question regarding non-stick coated utensils, so that's why Teflon is very important over here. Then next is polyacrylonitrile, next addition polymer. Now here it is prepared, the monomer here taken is acrylonitrile, and polymerization takes place in the presence of peroxide as a catalyst, and we get polyacrylonitrile. It is used as a substitute for wool in making commercial fibers as Olon and acrylan. So it is used as a substitute for wool. Then next we have condensation polymerization or step growth polymerization. This type of polymerization involves repetitive condensation and reaction between the two bifunctional or trifunctional monomeric units. Now in this reaction, product of each step is again bifunctional species and sequence of condensation goes on. So here each step produces a distinct functionalized species and it is independent of each other. So it is called as step growth polymerization. And here formation of terylene or decron by interaction of ethylene glycol and terephthalic acid is an example of this type of polymerization, which is a step growth polymerization. So to produce terylene or decron, which is important polyester, we use ethylene glycol or terephthalic acid to combine them together. Then some important condensation polymers are polyamides. First of all, we have polyamides. Under that we have nylons. So under nylon we have nylon 6,6 and nylon 6. Now nylon 6,6 is prepared by condensation polymerization of hexamethylene diamine with adipic acid under very high pressure and high temperature. So we get nylon 6,6. Now you need to know the characteristic about nylon 6,6. It possesses high tensile strength and also strong intermolecular forces like hydrogen bonding, and it is used in making sheets, bristles for brushes and textile industry. So these are the uses. Then nylon 6 is obtained by heating caprolactam with water at high temperature. Now this reaction is repeated, it is asked in the exam. This is a caprolactam, which is a cyclic structure heated at 533 to 543 Kelvin temperature to give nylon 6, and it is used in manufacture of tire cords, fabrics and ropes. Then we have second type of condensation polymers, that is polyamide. Under polyamides we have second types we have polyesters. So polyesters are the polycondensation products of dicarboxylic acid. So best example here is Decron or terylene, and it is manufactured by heating mixture of ethylene glycol and terephthalic acid at 420 to 460 Kelvin in the presence of zinc acetate and antimony trioxide. Then it is crease resistant and used in blending with cotton and wool fibers, and also a glass reinforcing materials in safety helmets. So this is the use of polyester, that is terylene or Dacron. Then next we have phenol, which is formaldehyde polymer, and in that we have bakelite and related polymers. So it is an oldest synthetic polymer and obtained by condensation reaction of phenol with formaldehyde in the presence of acid or a base catalyst. Then here the initial product, that is linear product, that is Novolac, which is used in paints. Now this is application type of question which can be asked for 1 mark. Novolac. Then Novolac, when heated with formaldehyde, undergoes cross-linking to form infusible solid mass called as bakelite, which is very important. And its uses, it is used in making combs, phonograph records, electrical switches, handles of various utensils. So this is how you can use the bakelite in different category. Then next is melamine, which is a formaldehyde polymer. It is formed by condensation polymerization of melamine and formaldehyde, and we get the melamine polymer, and it is used in manufacture of unbreakable crockery. So melamine is used. Now specific polymers and their uses are very important because question is based on that only. Then we will see copolymerization. We already have seen the definition of copolymerization, that it is a mixture of more than one monomeric species, and it can be made not only from chain growth but by step growth polymerization also. So here is the example of 1,3-butadiene. When styrene is combined, you get butadiene styrene copolymer. Its uses is you can use in the manufacture of auto tires, floor tiles, footwear components, cable insulation, etc. Then we will see second type, that is rubber. We have natural rubber and synthetic rubber. So in natural rubber, we it possesses elastic properties, so it is termed as elastomeric polymer. Then natural rubber, it is considered as a linear polymer of isoprene, that is 2-methyl-1,3-butadiene, and also called as cis-1,4-polyisoprene. So this is the structure. In rubber, we have very important process that is called as vulcanization of rubber. Now what is this vulcanization? When natural rubber becomes soft at high temperature and brittle at low temperature, shows high water absorption capacity. So it is soluble in non-polar solvents and is non-resistant to attack by oxidizing agent. So to improve this physical properties, process of vulcanization is carried out, and in that process, heating a mixture of raw rubber with sulfur and an appropriate additive at a temperature 373 Kelvin to 415 Kelvin is done. Then on vulcanization, it forms cross links at the reactive sites of double bonds and rubber gets stiffened. So the questions like what is vulcanization, then what happens after vulcanization are asked in the exam. Then next is synthetic rubber. Synthetic rubber is any vulcanizable rubber like polymer which is capable of getting stretched to twice its length. So it returns to its original shape and size as soon as external stretching force is released. So synthetic rubbers are either homopolymers of 1,3-butadiene or copolymers of 1,3-butadiene and its derivatives. How to prepare synthetic rubbers? So we will see one by one. Preparation of synthetic rubbers. First we will see neoprene. Example is neoprene. It is prepared by free radical polymerization of chloroprene. So this is a chloroprene which is undergoing polymerization to give neoprene. Now what are the uses? It is superior resistance to vegetable and mineral oil. So that's why it is used in manufacture of conveyor belts, gaskets and hoses. Then Buna N, and this is formed from 1,3-butadiene and acrylonitrile by copolymerization to give Buna N. So it is resistant to action of petrol, lubricating oil and organic solvent. So it is used in making oil seals and tank lining. Then polymers, molecular mass of polymers. They are closely related to the molecular mass, size and structure. So growth of the polymer chain during synthesis is dependent upon the availability of the monomers in the reaction mixture. So whatever product we get, the similar mass will be of the reactant and product almost similar. Then biodegradable polymers. So by the name only we can tell that what are biodegradable polymers. The polymers which can be degraded easily in the environment. So they cause acute environmental problems and remain undegraded for quite a longer time. So here we have two examples. One is PHBV. PHBV is poly beta hydroxy butyrate co beta hydroxy valerate. So it is obtained by copolymerization of 3-hydroxybutanoic acid and 3-hydroxypentanoic acid. So we get this particular biodegradable polymer, which is PHBV, and it is used in specialty packaging, orthopedic devices and in controlled release of drugs. So this is very expensive, that's why it is used in only certain devices. Then nylon to nylon 6, it is an alternating polyamide copolymer of glycine and aminocaproic acid. So this is nylon to nylon 6 and it is biodegradable. Then polymers of commercial importance, we have polypropene, polystyrene, polyvinyl chloride, urea formaldehyde, glyptal and bakelite. Now these are of commercial importance because polypropene, it is used in ropes, toys, pipes, fibers, etc. Polystyrene is used as an insulator, wrapping material, manufacturing of toys, radio and television cabinets. PVC, that is polyvinyl chloride, is used in raincoats manufacture, handbags, vinyl flooring and water pipes. Then urea formaldehyde is also used in used in making unbreakable cups and laminated sheets. Glyptal is used in manufacture of paints and lacquers, and bakelite is used for making combs, electrical switches, handles of utensils and computer disks. So these are of commercial importance because their uses are given as such. So this is about polymers, and this is for only 2 marks, 2 or 3 marks. So you have to study only specific things from this chapter. Okay, so with this I finish polymers, and I will continue with the next chapter in the next video. Thank you.